Hello, everyone. So today, this is a class. This is the third session. So in the last two sessions, we learned how to connect all our hardwares, electronic pieces, connect cell phones, something like that. And the second session, we learned a little bit about the Android Studio and GitHub. And this is this is homework for session 2. So I guess a lot of you already finish this homework and achieve it. So what you need to do is once you make your code works, then you just click this homework link, then click start task, then go all the way to the end, copy paste your code here. Okay?
Wait, how is that an upload button?
Just copy and paste now.
Oh, well.
Right? When you copy and paste, then click finish task.
Do we need to do it again?
You don't need to. Then you can click here to continue button, such that you can go to the next classes. If you don't do it, you don't have lecture notes today. Okay? So do it now. Okay? Question? If you already can see lecture 3, you can skip this one. If you can, you have to upload your program. If you didn't finish, you just type in any gibberish string there and upload it. Then you can upload later with the real one. I'm not going to grade your program today, but I want you to see the classes, see the class notes. Okay? Did everybody already do that? Okay.
Wait, Bing, what about ours? What do we do with, because our things are
Isn't it the same code?
or Word?
Yeah.
It's
No,
individual.
no, the
Yeah, I know,
code,
so
you make a change. Copy paste it, right? From Android Studio.
it's like gibberish.
Right?
Yep. But if you are finished, just paste it.
Okay. Has everybody already do so?
No, I'm trying to do that right
Okay. If you haven't finished, just paste any string there. Just type something. You can. Coach, I'm going to help you. You can type in a coach. I'm handing it later. Hand it in later. Right? So in that case, I know you are late behind the schedule. Okay. So let's start today's lecture. Today, you're going to learn how to write tele-op program. Okay? So from last 2 sessions, you know how to connect all the devices. And you know how to compile a code and check out the code and share with your teammates. Okay? You're going to run into lots of questions when you try to write a program. Try to go back to lecture notes, get answer first before asking me. Okay? So, okay, let's start today's lecture. The first things you need to do for tele-op control it is, in your last homework, I guess a lot of you already run into a problem say servo not found, right? When you try to run your program, your driver station has spit out a message say servo something not found, right? That's because in your code you say you try to get the servo. It's like here. Okay. Is this code looks familiar? Yeah. Is this code looks familiar? Right? Your code fails because your code says go to the hardware map, find a servo, right? Dot servo, then get a servo name, servo clock. Okay? If you forgot to configure your robot to add this servo, then the program will fail, because this is what we were trying to telling you right now is, in order to make your program works, you need to let the Android phone or your program know where is your devices, where's your server. Okay, so how to get a server? Basically, at here you can see your classes extends from a class called opmo, right? This opmo class was implemented by the FTC programmers. They wrote this code for us. If you have interest, you can right click. You can use a shift click this object in Android Studio and look at what's the code inside. But today we won't go there. Today you just need to know this program is a parent class which already building a lot of utilities to help you find your devices. Okay? You don't need to know the detail. But one thing you can try is in the code you in your last homework, if you do this, hardware map dot, okay, in your code section somewhere, and the Android Studio will pop up a lot of lists, right? This is all the devices currently the Opmo supports. If you want more devices to show up here, then you need to write your own classes to support us. See, at here you can see we saw a lot of sensors, right? Acceleration sensors, color sensors, compass, CR servo. CR servo is continuous servo, okay? DC motor controller, digital channel, gyro sensors, right? This is all everything we support. But in today's class, because we focus on the Tally-O, the manual control. So I want you guys to know how to control servo, how to control DC motor, and how to control servo. Okay? Because the rest of the thing is a sensor, which we will teach you to do in the next class. Got it? Okay. So you ready? Then let's explain the program. This is the program in your last homework. Let's explain one by one. So how many of you actually good at Java? Really good?
What?
How? So, okay.
What?
Okay, let's do it one by one, okay? Line by line.
What you said. What did you say?
Just in case you know Java.
Ming, what are you doing on your computer?
Nothing.
This is recorded. Your mom might hear.
That's true.
I'm gonna give you a shame comment.
For doing what? I'm not doing anything.
Okay, Ming.
Yeah.
I heard that you are a good Java programmer. Can you tell me what's the first line doing?
Oh, it's importing. It's importing the first package, which has a bunch of code in it, basically.
Is that true or
like
false?
stuff defined and like, well, sort of.
It's just saying where it is in the structure of the whole project, right?
Oh shoot! It's a package.
How do you know this?
What's the purpose?
It's
I don't
import,
know.
doesn't it?
No, it's not importing. That's the one below.
As a matter of fact.
Basically, the package is a Java command. You usually put in the first line of the code to tell the Java compiler where to find the other code. And also tell the Java compiler, your code belongs to this package. In this case, it belongs to a team code, right? So what's the nice thing about a package? The nice thing of a package it is you just need to load a package, load every code there. Basically help you to organize your code. Your code won't scatter everywhere. So this is why in the Android Studio, you can see that the Ruckus do a lot of has a lot of package. And here, the Ruckus has FTC robot controller. This is all the code FTC wrote for us. All the motor drivers, the communication protocol, How do you use the USB to talk to each other, right? How to do your Wi-Fi direct? Everything is here, right? Did you have to write any code to the Wi-Fi direct? No, right? So this is what you should not change any code in this package. Okay, should not, because you will break it. Another package is OpenCV libraries. We put it there. We haven't if in this semester you guys can learn fast enough, then I will teach you a little bit machine vision. Basically, how do you write efficient code to let the robot use camera to detect objects, detect colors, detect motions, then do the path finding. Okay, and here is a team code. If you do a fresh checkout from the FTC repository, the team code is totally empty. There's no Java code there because it's your code. Basically, all your code go there. Go to the team code section. Okay. So we have a lot of source code here because we are taking class, and we basically just hijack all the codes we wrote before and teach you one by one. Okay. See that? Got it? Okay. This is called package, right? Okay. So, and second line is we call import. Import it is because you're leaving this package called team code. Got it? But in order to use the op mode lives in a different package. Now, how do you load the object from the other package? You call this command called import. So this is all the package name. See, all the way to the end, right? So this is implemented by Qualcomm. Qualcomm is a famous microchip company, right? Qualcomm.
Sponsored by Qualcomm.
Okay.
Brought to you by
Hello. And the second, if you have an interest, you should take a look at the code. How do they implement op mode? Because that's a good way to learn how professional Qualcomm engineers implement things. Okay. And the second library you guys can need to load in is a teleop, right? Again, the Qualcomm guys implement lots of utility functions in a teleop object, so that you don't need to write like a DC motor drivers, okay? And the other thing you need import here because you are going to use servo, okay? So you need to import servo. Got it? Okay. The next line is called teleopen. Does that look like a function? Okay. Basically, did you guys see there's a @ sign before the teleopen? This is called macro, because this macro, which is defined at here, it implement a lot of things for you. This single lines of code, when the Android phone compile it probably will expand to maybe 300 lines of code. This is called macro. Macro, it is, you write a template. Macro basically is a template.
macro.
Okay? Macro, not a
That's
fish.
my mouse.
Yeah. See, let's come here to take a look at it. If you click this teleop, right, you can see that it is an interface. Okay, it's an interface, and it's taking a target, an orientation, taking the parameters in from the stuff at here. Then it's going to use this to expand it to create more codes. Got it? Okay. And according to the interface, you have to define a name and a group. This is a name. If you say teleop, it's going to show in a teleop session in the driver station. Got it? Right? This is the name, right? How many of you finish your homework? You can see that when you finish homework, you can see there's a training teleop icon shows up now, right? It's come from here. And do be aware that this tally op, this name has to be unique. If you put if you enter the 2 mode has the same name, it will complain. You cannot boot up your robot. Okay? And the second thing is called grouping, because the tally op icon in the Android, in the driver station phone, you have lots of icons. If you put in the same group, the program will automatically sort all icons into a session by session, help you to find it. Got it? Okay. So now let's go to the, this is how we define the classes, right? We have a tally-op teaching classes extend from op mode. When you use these classes, you have to save this class to a Java name as same as the class name, and it's also case sensitive, right? That's in the last quiz, right? Got it? Okay. And this, it is class member. Because we are your state machine, we need a state, right? Okay. And this state is going to show up right here, underneath it, right? And this is how we do the timestamp. Java provide a function called system.currentTime_minutes. If you call this function, the Java will query what's the current time and return you everything in milliseconds. Milliseconds to the epoch time. Epoch time, it is the times from 1976 something. They call that epoch time. Epoch. Okay. So it's things in milliseconds. This is why they need a long. Long, it is the large integer, really long. 60-bit, 6-bit. Okay. So then you declare a servo right here, right? And then you go to the init session. In the init session, you guys have to, this is the place you get the memory address of the servo for the configuration right here, right? Usually I will put something in the telemetric data such that you know you something is done in the init. I will encourage you to say put something more meaningful, not just say hello Java. You can say servo find like a servo founded or something like that to be something meaningful, right? And the next session you need loop. Usually if you want to implement like your own calibration, which takes long during the init steps, then you need to implement this in the init loop. Basically, this init loop is also a state machine. We implement init loop state machine in the init loop. It's like a loop in the second loop. Got it? Okay. And this, it is the function, the program will run when you click the start button. Okay? And here we just use that to memorize what's your start time. And you set the servo position to a default position. Got it? Okay. So then this is the fun part in the loop. Basically, in the loop, you need to say implement your own state machine. For example, on/off button, right? That's a state machine, right? Right? And this is today's class. Basically, in a state machine, you read the sensor, make decision, send a non-blocking command, and change state if you need. In a manual control, you do the same thing. Also read the status of the gamepad. Based on the gamepad action, you send a command to trigger a command, right? Right? Then change state if you want. And in the end, you need a stop button. That's a function. When you click stop. For example, if you want the stop button to stop your motor if something go crazy, then inside here you have to say motor stop. Right? Okay. Now let's talk about something about the hardware objects. in our code, you can see there's a lot of object called hardware magnet, hardware prototype, hardware spider, hardware Wifolia, hardware. Do you guys know why we want to implement that way? Why?
No, Coach, I got my computer to work.
Good. Good job.
I just had to change something.
Okay. Cool. Okay. So, do you guys know why we need to implement hardware class? Anybody guess? Because we have a concept. This is belong to object-oriented programming. It's called encapsulate. In order for you to make your code scalable, for example, you implement high-level routine, right? And this high-level routine is going to, you say you have two robots in your gym, prototype 1, prototype 2, and high-level routine is exactly the same. When you upgrade your robot to new robot, are you going to rewrite all the code? No, right? How do you prevent to rewrite all the code when you upgrade to new robot? It's very simple. This is called you encapsulate the robot function. You encapsulate the robot function into an object. Instead of calling like each motor or something individually, you call this object called hardware. For example, I'll give you one example, right? So in the last season, when people try to build a chassis, the chassis has a magnet wheel, okay? Then they just create a class called hardware magnet. It defines all the devices required for the magnet. Like you have 4 wheels, right? Let's go there, take a look. See, you have 4 motors, right? It's right here. Right? So when you make your chassis works, then your code works. If you want to swap out the chassis, then you just swap out then you upgrade the hardware spider. See that? And you can see that hardware spider, hey guys, this is the magic, guys. The hardware spider extends from hardware magnet. That means whenever you implement hardware magnet, which is the chassis functions, it's already been done. It's already been debugged, right? If you want to add arm to it, see, here you add motor to the slider, motor to the rotate, to the arm, to the brake. You don't need to write code for the wheels motor again. Got it? Got it? So this is why in the last season, our robot, our program, we can do a faster prototype about the program. And our program is very robust, not many bugs. Okay? Okay, let's focus on today's class. Today's class, you guys need to master, understand how to control DC motor, servo motor, and a continuous servo. Right? In the beginning, you just declare it. And in init function, you see, you have to get the wheel. You need to get the hardware and then get the name of the motor. And for the DC motor, you need to set a couple of mode. Because the motor, if you say motor power to 1, you can spin this way. It can spin clockwise. Or it always can spin anti-clockwise. Right? So, but in general, you want the power 1 to drive the robot forward. Power -1 drive the robot backwards. Now there comes a problem. Because the motor always rotates in the same direction, for the left-right wheels, they are turning opposite, right? So how do you solve the problem? Yeah. Then at here, you set the motor direction to be forward or backwards. Got it? If it's that means for the left view, you have to set this option to be forward. For the right view, you have to set this option to backwards. As a result, when you set the power to 1, all the motor push the robot into the same direction. Got it? Got it? Everyone got it? Okay. And we also need to have this command called stop and reset encoder. This it is very useful function to set encoder to 0. Do remember the motor encoder just keep increasing. When it reach a limit, you will have a gap because the number in the computer memory has a range. It has a maximum number, have a minimum number. When you keep increasing, when the number go to the maximum number, you will right back to the minimum number. Got it? So if you have a really long motor runs, I would recommend occasionally you do a reset encoder after you complete one operation, because you will prevent this called data overflow problem. Got it? Then I will explain this mode later. Okay? Very specific to motor mode. Okay? So, and for the servo control is really easy. You just need to get the servo and don't need to set any mode, because the mode is pretty simple. For the servo, it turns by the angle. The servo number range from 0 to 1. It depends on how many degrees. It depends on what servo do you buy. If you buy a servo which has a moving range from 0 to 180, that means 0 is 0, 1 is 180. If you buy a servo which can only move by 60 degrees, then the 0 is 0, 1 is 60 degrees. Got it? So this is here. Servo set position 0 or something. Okay. So when you start the robot, it's good idea to always run this command: stop and reset encoder. That will make your encoder to 0. And it's better if you want to use the encoder, then you can say motor run using encoder. Right? And you need to set set the power to 0, just in case you got some leftover commands. You just make the robot just go before you ask it to stop. Okay. So you also need to set the servo into the 0 positions. Right. So to stop function, you just set motor power to 0. Okay. So okay. Then we move to the second session. Can you guys do this practice? We want to explore what's the option of this gamepad, right? This gamepad have left joystick, right joystick, X button, Y button, X, Y, left bumper. This is left bumper, left trigger, right trigger, right? Okay. So can you guys go to your Android Studio and try to see, you saw these options, because you can see at here, this is button A, button B, the back button, the gamepad button, it is this thumb, gamepad left is this one, gamepad right, it is this button, gamepad up is this button, right? So can you guys go to the Android Studio? I want you guys to see this to make sure you can saw the pop-up. What you can do is go to the loop function session. Go to loop function session and type either gamepad 1 dot or either gamepad 2 dot something. You will see things pop up. You see? Let's go to loop function. Go to loop function.
The air smells smoky. The air
It's
smells
actually kind of weird.
smoky.
Yeah, it's a fire somewhere. You can see the smoke coming from outside.
I told you there was a smell. I thought it was like ghastly. I thought we just had another wildfire.
Can you guys close? Somebody close the door. Close the door.
What is public void gamepad control? Do we need to like write that in here, or can we just use the loop?
Just write something. Just write something in the loop function. Just loop function. Inside the loop function. Okay. Right here, you type gamepad. Gamepad 1. Gamepad 1. See? See? This is all the devices supported by no in the loop function. The loop function inside the loop function.
I'm sure we already have public void, so you should be fine.
Okay. Got it? Okay. So you guys need to find out what's this thing one by one. Don't be aware, okay? So in your code, don't assign the same function, multiple function to the same button. That will make things really weird. And sometimes it will make things into infinite loop. Yes, sometimes it will make this into infinite loop. Right? For example, your function A call function B call function C call function A. Is that loop? You never finish. You will feel strange. Why am I in a tele session? My robot just go crazy. It's non-stop because you have a bug somewhere. Function A call B call C call A. Okay. Yeah. Now. Now we talk about a motor. Hey guys, can in the loop session, when you type in DC motor dot run mode dot, you can see there's a couple more pops up. Hey guys, attention please. This is a very important concept. If you don't understand how do you control the DC motor, the motor will behave really weird. Okay? In the DC motor, there are 3 modes. One mode is called run to position. The second one is run using encoder. The third one is run without encoder. Run to position, the concept it is, you need to set a target value. And when you set the power to the motor will try to go to the encoder position and keep running it without a non-stop. Okay? You will stop only reach the position. It's sort of like the PID control we wrote, move by the distance and stop. Okay. Internally, if we use the PID module inside the expansion hub to do the same. Okay. But the PID control inside the expansion hub is not that good. Okay, because it never consider the robot weight, just a value. It won't work right. Okay, and run with encoder, it is when the motor runs, the motor will keep checking the encoder values. Okay, run without the encoders, the motor just if you set the power to something, it just run, doesn't bother to check encoders. If you want your robot to run really fast in teleop mode, right? If you don't care what encoder to use, then you should use this mode because this is the mode has response fast. Got it? So that means in teleop mode, I would recommend you guys use this run without encoder.
Did we use that last one?
No. This is why in last season, when the encoder breaks, some wheel will spin fast, some wheel will spin slow. Right? It's simply because it's checking encoders and doing something funky.
Why didn't we use that last?
Because because I haven't thought about it. This year in teleop mode, if you don't care the encoder location, set to this mode because that gives you highest performance. Okay, and even your encoder cable is broken. In last year, if one of the encoder cable is broken, that wheel will move fast, make the robot go not straight, right? Then we have to fix it. If we don't care the encoder location, why don't we just turn it off? That actually give us some avoid this problem. Got it? Alright. Then here I just show you how do we switch modes. For example, there's a utility function here. Say in order to use the run to position, hey guys, listen. In order to use the run to position functions, you need to first set your target position. Run a command. Set target position. This code is provided by Qualcomm guys. Okay? Then you turn on this mode. Then set power. Okay? Got it? Okay. So the trick, you have to be careful. If you have to do gentle movements, if you set this power too high, you will burn. Remember last year, we used this command to hold position, right? We set 1 to hold it, basically just burn out the motor, right? So then basically, this is a function to hold position. Say if you want to move to somewhere and hold, then you need to use this, right? This is very useful for arm, not quite useful for wheel, because we have very few cases we want to hold position. Unless this year there's a requirement that you have to hold on a slope. You park on the slope and hold it there.
That was rescue. I don't think they do that again.
All right. All right. Then if you want to switch back into the other mode, say if you want to break this mode, you simply just set the motor to different mode and set the power. You break out from the mode. Okay? This is why in last season we asked the arm to hold. But as long as you push it to change the arm position, power, immediately the arm will move again without holding it. Got it? So basically, to switch the 3 modes, you just need to set this mode back and forth. Okay? And since we have a long lecture today, you guys have to go back home to understand this code. It is the code to use joystick to control 2 wheels, 2 driving wheels to turn left and right and moving back and forth. See, we read the joystick Y position, front and back, as a throttle. The more you push to the front, the faster the rotor moves. And we use joystick X direction, which is left or right, to control the direction. What it can do is, you can see that we just simply do a simple trick, throttle plus minus direction. In this way, we send differentiation force to different left-right motor, so you can turn the robot. See that? That's a really slick trick, right? So this is a trick. A lot of teams they don't know this trick. They have to use the left joystick to control left wheel, right joystick to control right wheel. So you basically waste 2 joysticks, right? Got it? So we use 1 joystick, we can control 2, right? So for the mechanism wheel, the control is more complex. I would recommend you go home to understand this code. Right?
Why would we have 2 wheels?
2 wheel has less traction. If those 2 wheels get stuck by something, a robot got it.
No, how would the robot balance on 2 wheels?
Positive feedback loop. It's a segue. No, we should only do that.
Hey,
Oh
you
my
you
God.
you can
I
install.
wish we didn't decide
Like
to
the
do
rover rocket's rover.
Hey,
Oh.
That's true.
you can install 2 omni wheel on the front and 2 omni wheel on the back. So
That's
it's
4
still
wheels.
You
That's
balance.
4
You
wheels.
balance.
But you only drive 2 wheels,
Omni wheels.
Yes.
right?
No, but that you still have to use all 4 wheels.
Yeah, but you only drive 2 wheels.
Yes, you have to
Oh,
leave it
you can
paused for
stand on
a
2 feet. You don't need 4 feet to stand.
But your feet aren't
What do you
round.
mean? I need 4 feet.
Okay, hey
Are your
guys.
feet round?
Exactly.
Are your feet? No. Are your feet?
No, is your entire lower
Then
body
how do roller skaters stand still?
They have four wheels on each foot.
Yeah.
You thought they had one wheel
No,
on
no,
each
no. I
foot?
know they have 4. I was just thinking.
You only see that in the movies.
No. Actually, they have 1.
Alright, hey guys, this is
The
a.
4 is the government.
Hey, you guys are on air. You guys are on air. guys, do remember. Okay. Okay. For the magnetic wheel, because the magnetic wheel has like 40-degree smaller wheels on the wheel, right? That means the orientation of the wheel installation is critical. You feel?
Now's not the time to be looking at Mac computer cases.
If you install the magnetic wheel in the wrong orientation, and this code won't work. Got it? So basically, the magnetic wheel orientation have to map this wheel. So this is why I want the robot back today, because I need to take a picture of the wheel. Because this code only match the current magnetic wheel settings there.
Well, you could kind of try to use logic to figure it out.
Okay, you probably burn your all brain cells.
That's what I tried to do last season.
Right? So since it's so tricky in the magnetic wheel, the best way to figure out what direction it is try and error. Okay? But why not just copy exactly what we already work, right? Because this code only works with the orientations. Then we just always use the orientation. The wheel orientation, right? Without, right? Okay.
Did you pick one? Oh. Oh yeah, that's there for some reason, honestly.
Hey guys,
I don't know.
guys, focus. I know today's class is a bit long, okay? But you need to focus. This is we only have a few concepts left, okay? The other concept is called lookup table, called LTU. So basically, a lookup table it is you use basically this is a table, right? By look at the table, you map one X value here to a Y value. Why it is useful? Because we can use lookup table to adjust the servo the joystick sensitivity. Because when you push the joystick, center position is 0, far position is 1. If the motor moves really fast, then you have to really hard to control it, right? Then how to make it less sensitive? You write a lookup table. For example, you map half throttle to power 0.1. By default, half throttle, you map power to 0.5. For a light robot, power 0.5 is really fast, right? If you want a small adjustment, fine-tune adjustments, no way you can get it. I know most of your drivers still slam the throttle to drive it.
I had
Right?
to adjust it last season.
Right?
No, not me.
So the best driver it is you learn how to use half throttle to control things. Okay?
Wow.
Okay?
When you
So,
learn to use
How do you
When you move the like joystick this much, like halfway, and it's full.
okay? So basically, in order to make it, you have a chance to go to fine tune. I will map half throttle 0.5 to motor power 0.2. Got it? You map 0.1, 0.25 throttle position to 0.005. So in that case, you have more room for like a low power fine tune. Got it? Got it? Everybody understand this concept now? So that means in order to be a good driver, you also need to be a good programmer, basically to fine tune this curve you like. Okay? So
or you could just have good communication.
no way, because this is
Because we had excellent communication last season.
Okay.
Well, I mean, it worked good enough.
Hey guys, take a look at here. So it is a simple lookup table we implement. You can see that this is an array, right? In the Python, in the Java, this is an array, right? You can see that in the middle of the array, middle point of the array is 0.3. That means if I use this as a lookup table, when I say go to throttle 0.5, actually you only apply 0.3 power to it. If you go to 1/4 of the throttle position, you only use 0.08 power to it. Right? Got it? This is how we implement it. And how to use it? It's very easy. First, you read out the joystick location. Then you call this utility function to map your joystick location to the real power. Got it? Got it? Okay. Then we go to next servo control. You guys already know this. See, this is a really dumb way to implement the servo control. You press left bumper, you set to position. Press right bumper, you set to another position. We can use on-off button, right? So they will prevent us to, right?
Wait.
You can give
so
us
what's the smart version?
what?
So what's the smart version?
Toggle.
It's for toggle.
Oh, that's what. Okay, I see. Never mind.
Right, this is the toggle version, right? So you can do the same thing for the servo control, okay? So okay, let's take a look at the homework. Uh-oh. I need to switch this. Let's okay. So we have a couple of homework in next week. Basically, they're all programming tasks. Okay. So, for example, you control robot going forward, control robot going backwards, right? So, I expect you today or next week fix your robot, make your robot function.
Done.
Got it?
Remove the entire side panel though.
We'll do.
We're just gonna start on these.
Right. Okay, this is for today's class. So do remember in next class we have a quiz. Right now I didn't turn on the quiz because I don't want you guys to do ahead of time, right? Okay. Cool. So okay. So this is today's class and see you next week.
Oh, I heard
The
that.
robot wasn't so wires, and Elena and I were trying to work it out last
What are you researching the whole time?
No, just right now.